All right, hey, good morning. We're going to learn how to graph an exponential function. And so first off, we have this nice chart here to look at. Here's our equation. 4 times 3 to the exponent power x. And we have a graph right over here. So what I want to first off do is this. Just think of this as the following. Remember, f of -1 will be 4 times 3 to the -1 power. That is the same thing as 4 times 1/3, which would give me an answer of 4/3, all right? Or if you wanted to have a decimal, it would be 1.333 repeating, okay? I'll make it a little easier when we come to graphing. To do f of 0, we'll have 4 times 3 to the 0 power. Well, remember, anything to the 0 power is 1. 4 times 1 is 4. All right? And then let's do f of 1. Will be 4 times 3 to the first power, which will be the same as 4 times 3, which will be 12. And then to the second power, the same as 4 times 3 squared. Well, 3 squared is 9. The order of operations, I would do the exponent before the times. 4 times 9 would then be 36. Right? And then to do f of 3 will be 4 times 3 cubed, which 3 cubed is 3 times 3 times 3. Well, that's 9 times 3 makes 27. So I have 4 times 27, and 4 times 27 will be 108. So when I go over here to graph this, I'm going to have a point at -1, and it will be at 1 1/3, a little bit about right there. At 0 will be at 1, 2, 3, 4, right there. And then at 112, we're already way up here. 236 is going to be way up there like that. And I know this exponential function is going to look something like this here. And I know this one's going to curve out. I believe it's going to be looking like right here. It's going to get real close, I think, to, I got to look at the next thing, -2, 1/9. Forward, yeah. It will be, yes, it will be this right here. It's going to come down and it will get very close to this 0, but will not ever quite touch it. All right? So, an exponential function is going to be like have an asymptote here. Never quite ever touches this, because no matter how close we make these numbers here to be a fraction really, really big, to infinity, there's still some number above it, so it never quite gets to 0. And then here it's going to go to infinity very, very quickly as an exponential function. Now, as we graph that, you got to think, is there an easier way maybe to do that, especially since we have calculators? Yes, I'm going to erase that part right there so the calculator part will show up a little better. And if you come over here to your calculator, we'll turn the little calculator on, and we will get the following. First off, let's turn the calculator on. All right. And what I want to do is this. I want to go to my y equals button. Okay. And I'm going to type in exactly as it is right here. 4 times 3. And I need an exponent, so I'm going to hit this. And now I'm up here going to hit x. And I can hit graph. And if you'll notice, my graph's going to look very close to the same. You can't see it right here, because it gets very, very close to 0, and you can't really distinguish that line from the other. Graphing calculator is not that great. But look at the second table. Oops, sorry, second table is the one we want to hit. And notice, we had the same values here. At -1, we had that 1.333 repeating. At 104, we have 112, 2, 36, and 3, 108. So we get the exact same numbers that we have right there. That's really cool. Makes it really, really easy. Okay? Now then, let's do this right here. And I'm going to go back and minimize this one again. And let's roll up. And let's look at the second problem. Oh, something I do want to mention is I roll that back down right there. Something that was forgotten. If you look right here, you see the little thing moving around? At 0, we had 4. Notice, what is the number right there in front of that? 4. And if I was to take this number and divide it by 4, what's 12 divided by 4? You would get 3. It's going to be real important for foreshadowing something here in a second. Okay? So first off, let's look at this new one. That's not the exact problem we have right there. It's a little bit different this time. So we'll erase these here. We'll do these in green just to show that they have a little bit different problem here. I might go to my calculator, do the y equals button. We'll show that here in a second. But first off, if I have f of -1, it'll be 3 times 2 to the -1 power. Well, that -1 is the same thing as 3 times 1/2, which will make it 3/2, or we could call it 1.5. F of 0 will be 3 times 2 to the 0 power. And what's anything to the 0 power is 1. 3 times 1 is 3. Then we have f of the first power, which will be 3 times 2 to the first power, which will be the same thing as 3 times 2, which is 6. And then we have f of 2, which will be 3 times 2 squared. 2 squared is 4, so 3 times 4 is 12. And then we have f of 3, which will be 3 times 2 cubed. 2 cubed is 8, because that's 2 times 2 times 2, which makes 4, which makes 2 more, which makes 8. So it's 3 times 8, which makes it 24. So when I go to graph this, and we'll have a point at -1, 1.5, at 0, 3, at 1, 2, 3, 4, 5, 6. And 212 would be up here, and 324 would be way up there. And this was going to approach very close to 0. If you look at the negative values for x, it's going to look something like that there for this graph. Very similar to our other graph. One thing I do want to point out, though, is this. Notice, at 0, we were at 3. What is that number right there? And the reason for that is because when you take anything to the 0 power, it becomes 1. So therefore, I already know what my factor thing is going to be right here, my number I'm multiplying by. And then the number that's inside here, think about it. 3 to go to 6 had to double. 6 to go to 12 had to double. 12 to go to 24 had to double. All these numbers are doubling. 1.5 to 3 is doubling. So that means I know I have a 2 as the number that I am presenting to the exponential power there. All right, now, just kind of to look at it on the calculator. We'll come back to our y equals button. We'll turn our calculator back on. And we'll see what we have here with it, how easy it can make it to work out. So I'm going to turn it, it's already on. Go to my y equals. Let's clear that old one out of there. And we have 3 parentheses. 2. I'm just going to type it exactly the same way it is right there. Does it look exactly the same way it does right in there? Let's look at the second table. Notice -1 is 1.5. 0 is 3. 1 is 6. 2 is 12. We have the same numbers. And if you want to look at the graph, you can check our graph, and it looks the same right there. I think it turned out to be very, very well. So, right, that is how you graph exponential functions, either with a table, or you could use a calculator to work on those. So, once again, that's an easy way to graph an exponential function.